All right, for the next step in designing your catapult, I just wanted to discuss a little bit about the fastening techniques. You could fasten your joints with nails, with screws, with glue, and all of those methods of fastening are very good, and they're all very practical depending on the situation you're in. You have to decide which type of joint would be most beneficial. Sometimes it's good to tack pieces in place while the glue's fastening. Other times it's better to use a screw. So if you did want to unscrew it and redo it, you have the ability to take that joint and make changes or modifications if you aren't completely sure that that's the way you want to go. Many times that's good to put pin nails in, get it all set up the way you want, and then once you know that's the way you want to do it, you can unfasten the pin nails, glue it or screw it, and you're ready to go. Now, another method for fastening is to actually design it where you can make adjustments and it's intentional, where you can make modifications and you can make changes, and that's what I want to discuss in this video. If you look at the top brace that we put in here, we talked about its function is to create support going across the middle to stop the columns from getting pushed together, but it also, or from collapsing towards each other. But it also has the requirement of having the arm come up, and it actually runs into it. And it works to figure out the angle of your catapult when it releases the marshmallow. So this is something that you may need to play around with to get the ideal location. So I would think this would be a part of your catapult that you want to make functional at different locations on the columns, or you want to make it so you can modify it until you do get it completely right. And I'm just going to show you one method you could use. There are different ways, but you can make an adjustable dowel system here, where you could actually put holes all the way through here, and you could let this move up and down to different sections on the column, and you could, so that would be one way of modifying it. And if you're to put the dowels in, you'd probably just want to find center and make your line, and then make some kind of a measurement, like maybe you want to put a dowel every inch. I'm not sure what you'd want to do. Anyways, I'm going to show you one way of setting this up to put a dowel through, where you could have one dowel in place and you could adjust the piece of wood. Maybe you're going to have various lengths of wood that you could put into this spot, or maybe you just have one. Anyhow, I'm going to show you one idea. Like I said, there's many ways of doing it, and I don't want to take away your creativity by making you follow my bad design ideas. So I'm just going to go across here, and I'm just going to do a cross reference on this section, and hopefully that lined up. Yeah, so it went ahead and it lined up these lines that I brought out. I just wanted to find out exactly where center is here. So if I did drill through, it would go right through the center of this piece of wood. All right, this will be your next lesson in math. So we're going to go ahead and we're going to make a circular cut here. So you're going to be using a drill. So we're going to have to make a circle, because we're going to put a dowel through here instead of fastening it. So I'm just going to pull out on it. And as I pull out, down here in the corner, you can see it's showing the radius. Now, 3/8 of an inch is the radius. 3/8 is showing the distance from the center to the outer part of the circle. And that's not how I buy my dowels. I buy dowels and they tell me the diameter. They tell me the distance all the way across the entire circle. So we're just going to go do a quick math lesson here. If I was to go in and create a shape, so we have our circle that we create. So there's our circle, and inside the circle, like I said, if we were to go from here, let's try that again. If we were to go to here, from here to here, that would be your diameter. I just gotta get a different colored line here and make it a little bit thicker so you guys can see what I'm doing. So I'm gonna go to the weight, change the thickness, and let's go with black line. You should be able to see that. So there's the diameter. And like I said, when I'm doing this when I'm purchasing, I get a 3/4 inch in diameter dowel, but in this case, we're actually just trying to find the radius. So we're going from the inside and coming out, and that's what we're trying to figure out, is that distance right there. In order to do that, we got to do some math. So here we go. Here's your math lesson for the day. I'm just going to bring this down. So this is what we're dealing with. When I purchased the dowels, they're 3/4 of an inch. Okay, and if you're doing your math correctly, 3/4 of an inch is the same as 6/8. Correct? Please tell me that. I hope I get my math right here. All right, now that we know that's 6/8, that's an easier number to break down. So if we wanted to take 6/8 and break it down and make it half of that distance. So right now this is showing the diameter. Okay, we actually want to find out the radius. So the radius is going to be half of 6/8. So that's going to be equal to 3/8. So 3/8. So this is the number that we're going to have to punch in when we do the catapult measurement, and that will give us this distance from the center to the outside, which is half of 3/4. All right, so we're going to go back and we're going to put that number in. So here's what we have. Oh my gosh, look at that. Did we get it right? Okay, I'm going to put in 3/8 inches, enter, and that is the actual size of our dowel. So that's perfect. Now that I have that in place, these reference lines, we can get rid of those. So they are now gone. And we have our dowel that's going to go right through the center of this entire piece. So I'm going to go ahead and take the middle of it, and I'm going to push it all the way through. I'm going to snap it onto this other edge, and we now have a hole that goes all the way through the dowel. So that hole is going to show us the dowel that's going to go inside. So if you want to make it so it shows the dowel, you can do that. Right now I made it so it shows the hole. If you want to change it, you could take this piece, and I could use a control and pull out on it just to show the dowel sticking out on this end. And then I could take and use the push tool and push it through the other side. So I'm not sure if you saw what I did there. I'm going to do it again just so you see exactly what I did there. So we got it in the middle. I'm going to pull out on it. After I pull out, I'm going to click down on the control key. So it's going to start a new line, a new piece, and I'm going to push that piece. You see how it's taking it afterwards, and it's going to pull it out to the other side. So I have a dowel that's showing that's going through. If you don't like how far it's coming through, I can go ahead and push it back in. Okay, so it shows and it represents that there's a dowel going through, and that's holding it in place. So what I'm saying is you could have a hole there, and then if you wanted to have another hole up higher that shows that this is an adjustable system where you could move this up and down. And of course you'd want to go ahead and reference this and do it on the other side, or do that same cross reference with these and put the 3/8 of an inch radius right in the middle. And that would give you your design idea. That would give you an adjustable brace that could change the angle of impact that your arm has on the actual catapult. All right, I hope that made sense, and I hope you enjoyed my math lesson for the day. I don't get to do that very often. Good luck with this part of your catapult.